In this video again I look at information coding. Although the objective behind this design was to try to come up with a error detection correction method, it turns out to be a very good data compression method. So this is a video that is basically looking at data compression. Simple method for data compression, which should be really very effective. So we have to map a number, a value which is say k, which is less than equal to m equal to 2 power l dash to a value v which is less than equal to s equal to 2 power l. This is pretty much what we have to do, right? Now l dash is equal to, let's say, d times l. Right? Now a natural idea, so the l dash weights, as we can start off here, this is the 0th bit and this is the l dash minus 1th bit of the information, right? So we have l dash bits here. Let the largest weight be w. Okay, this will be 2 power l dash minus 1 will be the largest bit, 2 power l dash minus 2 and so on, right? And this will be 2 power 0. In other words, the weight of the ith weight will be two power I. An obvious thought that most likely occurs to it is to take the dth power of I, right? But that does not always preserve the order. Nevertheless, this can be written as 2 power floor of I by d times d plus I mod d, right? So what happens is, you'll have, this can be written as 2 power floor of I by d plus I mod d by d whole times d. Then you can take the dth root, right? But the problem is this is nothing but, let floor of I by d equal to q and I mod d is equal to r. So this can be written as nothing but 2 power q into 2 power r by d whole power d, and you can take the dth. But the only problem here is, if you take the dth root of the weight, is this is nothing but, right, 2 power, the summation of 2 power r for a given value of 2 power q, summate 2 power q plus 1 by d, sorry, 2 power r plus 1 by d by 2 power r by d is equal to 2 power 1 by d, right? So in other words, right, it will not preserve the order, but we would like it to preserve the order at the same time. Right? So let's look at it again. There's a simple way of doing it. We have the 0th bit of the information here and the L dash minus 1th bit of the information here. Let the weight of the largest bit be W. This will be W by 2. This will be W by 4, and so on. So I start by taking the dth root of W. You will get dth root of W. You take the dth root of the next weight, you will get dth root of W by 2 is equal to dth root of W by 2 power 1 by d. But you would like it to be equal to dth root of W by 2. So you have to multiply this by into 1 by 2 power d minus 1 by d. Now let's take the dth root of W by 4. This will be nothing but dth root of W by 2 power 2 by d. But we would like it to be equal to dth root of 2 power 2, or dth root of W by 4, right? So you have to multiply this by 1 by 2 power 2 into d minus 1 by d, right? That is nothing but 2 power 1 by 2 into d minus 1 by d square. So similarly you can see there is a pattern emerging here. So you take the dth root of the W and multiply it by a value r or x equal to 1 by 2 power d minus 1 by d power I, right? So the algorithm becomes fairly simple, right? For the, right, you take the dth root and then multiply it by 1 by d 2 power d minus 1 by d power I, whatever is the L minus, right? So you square. For the W by 3, we can also see similarly what will happen. It is the same thing only, right? So you can do, the algorithm is very simple. right? Let's start off with by setting I to L dash minus 1 and the weight W to 2 power L dash minus 1, right? The value to be coded to 0 if the ith bit is I, right? While I greater than or equal to 0, of course we will need to set comma j is equal to set j to the value 0, r to the value 1 by 2 power d minus 1 by d, right? Or j you can direct simply set it to 1. So you add to v plus dth root of w, right? If the bit is 1, if bit is 1, only if it is 1, okay? So we can write that also. If ith bit is 1, then v to v plus dth root of w, or you can simply set r equal to, what you could do is then set r to 1 here, if ith bit is 1, then add to the hash value dth root of w into r, right? Set r to r into 1 by 2 power d minus 1 by d and increment I. So this is one way of doing it. You just take the dth root of the weights, but you multiply each time by r square after taking the root successively from the left onwards. So this is a simple way of maintaining the invariant wi plus 1 is equal to 2 times wi, right, while doing the transformation. So here you will have to make what is not standard, but you will have to keep the fractional part also. So in other words, you will have to write code for, say if you have a certain number of bits is reserved for, I would say take equal number of bits, L dash equal certain number of bits here. If you are dividing by d, so slightly more than d, d and d a little bit more than d or more bits here for the fractional part, and right, the quotient part will be this, so it will come out to be very small. So this will ensure. Another alternative approach is, this is a simple way of doing it without too much clutter, which provides excellent data compression at the same time without being too complicated or too much clutter or confusion there. Another alternative way is, we saw that we can write this as 2 power I as, another alternatively we can write this as 2 power q times 2 power r by d whole power d. Now we can afford to take the, now what we do here is we replace 2 power r by d. If you take the sequence, you can find out the GP sequence. The sum of the lower order bits will exceed that of the bit for the next one, so it will not preserve the order. You would like to preserve the order. So you can simply write this as 2 power q times into 2 power 1 summation 1 by 2 power d minus r, right? Now consider 2 power q times summation 0 less than equal to r less than or equal to d minus 1 2 power 1 by 2 power d minus r. This will add up to slightly less than 2, very very slightly less than 2. 2 power q will be slightly larger than this. 2 power q plus 1 will be slightly larger than this. So in the first case, when q equal to 0, this will add up to 2. When you take q equal to 1, it will come slightly less than 2, slightly less than 2, very very slightly less than 2. This will add up to 2, this will add up to 2 plus 2, slightly less than 4. But this 2 power 2 will be coming to 4. So like that it will add up. It will come up closer, and you will get the integer part there similar, and the fractional part there as well. You can do this also. Another alternative approach is this. These are a couple of techniques which you can use for compressed coding information. They can be